Thank you, Professor Zhang. Hello, everyone. My name is Yumao Lu. I'm leading Microsoft Bing News engineering team. I've been in this position for the last 4 years. Today, I'm very happy to be here and present you AI for news search and recommendation. I am here to call for actions. Because when I look at the past and look at the future, I realize it is a critical moment for us to work together and to make an impact. Before we look at AI, we have to look at what we have now, what we are capable of without AI, and what is missing here. Then we can really feel the urgency and why we need it. That's the purpose of this presentation. We start with the product video, our latest release, Professional News for Dynamic CRM. So this product is powered by classic search and recommendation architect. We're going to provide an overview on it. Now I'm going to give you the future of news reading experience in my mind, followed by our product video on News Pro. Then I'm going to introduce AI as a framework to empower the advanced user experience.
Find out what's going on with your customers before your competition does with the company news timeline for Microsoft Dynamics CRM. Your CRM admin can add the solution for CRM Online if your organization is running Microsoft Dynamics CRM Online 2016 Update 1. Once the company news timeline solution is installed, you can see the company news timeline on the account, contact, lead, and opportunity main forms in the CRM mobile apps, and have access to the latest news from the most popular and trusted digital news sources. Relevant news articles are automatically categorized for quick and easy consumption as you review other account information. If you're a CRM admin, here's how you'll add the company news timeline to your CRM Online organization. Go to the CRM administration site and select the CRM instance you want to add it to. Then click Solutions, select Company News Timeline, and click Install. Accept the terms of service, and then you'll see the solution status change first to Installation Pending and then to Installed when the installation is complete. That's it! Users in the organization can now stay on top of the news and on top of the competition.
The company news timeline for Dynamic CRM is a very interesting problem. Why? First, you need to nail the scalability, because we have to provide timely, fresh, authoritative news for more than 1 million companies. That's not easy. Second, we have to be able to nail the precise user intent and be able to keep tracking change of ownership, change of leadership, product release, product recall, etc. with very high precision. Third, we have to be able to accurately deliver the news to the very targeted salesperson. So all three problems are very interesting and very difficult to solve, and we solved together with our partner. So this, of course, is an enterprise version, and not every one of you can try it, but there is one. There is a civilized one, consumer version, that is called News Pro that you can actually try, download from iOS and Android. The download link is presented in these slides. To enable such large-scale, high-precision, and very targeted news recommendation based on search, so we have to understand how search works and what is the news search problem on top of general web search problem, and how news recommendation based on search works. Search engine infrastructure is largely based on inverted index. The first core problem of inverted index is how we separate documents. Shall I, in my turn, specifically or sharding by documents. Sharding by documents in general is more popular because of its fault tolerance. As a few machines failure only means the drop of availability of a small portion of documents. The sharding by turn, however, provide much higher machine efficiency, so you can search with much larger document size. The next problem probably is matching. How do we get rid of the documents that are irrelevant to the topic of the query as soon as possible and as much as possible? So there's the idea of removing the positions from the position string. Or even better, we use Bloom filter to find out the for sure negative cases, and we allow controlled false positive to reduce the random access to the more expensive index. The L2 problem is where a user sees the ranked list of documents, basically the precise ranking problem. I think for this problem, the core is to get proximity right. Why? Because proximity is where the NLP, the natural language processing, and information retrieval merit. Arguably, how to calculate proximity is probably one of the most popular interview questions in the search industry. The minimum distance. Find the minimum distance between multiple sorted array. The existence of a linear algorithm of calculating this minimum distance is the very reason that proximity is a tractable problem in the search algorithm. Of course, relevance is far beyond proximity. In my opinion, relevance has 3 layers. At the very bottom, it is the basic, very classic bag-of-words model. One of the most popular one probably is BM25. BM25 is essentially an improved TF-ADF model with the concept of frequency saturation. BM25's term frequency is normalized so that when the term frequency is very high, the contribution of that term frequency to the relevance score is plateaued. BM25 is extremely fast and efficient and very suitable for the first stage ranking. However, its lack of notion of semantics and the accuracy of this ranking is problematic. To get very accurate top result right, so people have this idea of leverage users' search habit and search usage. So the pseudo relevance feedback leverage search result page and using that search result to extend or augment query and use that augment query to get better search result. Implicit relevance feedback, on the other hand, leverage user clicks. So the query is used to augment the document that are clicked from that query. So those click signals can be very accurate and very effective, especially combined with BM25. It, however, requires cold start and may hurt relevance, because accumulation of clicks takes time, and tail content, the clicks for that is very sparse. At the very top, there's a learning to rank system. For good learning to rank system, it is able to incorporate very large set of features, and those features can be heterogeneous. The 2 popular models may be gradient boosting tree and neural net. both models are very capable of taking heterogeneous feature that requires very little feature engineering and normalization, to the extreme that GBDT does not even require a feature to be numeric. So the feature can be a symbol. So GBDT can learn with symbol. So learning to rank is extremely flexible and powerful. However, those models mostly are not human explainable. So when you look at two models and give you different ranking of the two documents for the same query, it's usually hard to explain what happened and why. And also, this kind of ranking system does not serve sub-intent well. It's primarily serve the main intent. For news search, relevance is no longer the only story. So we have to take in freshness into consideration. We have to take in source authority, which is very subjective, into consideration. So the core of news search is really to get the supervision right. So how do we compromise relevance, freshness, and source authority into our supervision, into our labeling system? So that's still open question, and I encourage you to think about it. Another problem is triggering, because majority of news search actually happened in web search, and users don't go to news vertical to search for news. Right? Users just stay on the web search and search whatever they like, and we need to decide it's time to show news result. Is that decision based on query? Is that decision based on document? Or is that decision based on result? If that decision is based on result, basically you get news search result and you take a look at it's good or not. And then make a decision based on that. The next question I would like to ask is, how do you make it available before the actual search happened? Okay, there are many ways of doing it. I think that's a question to you to think about as well. News recommendation is actually a very hard problem. Until today, I believe no one in the world can proudly say they solved the news recommendation problem perfectly. If you compare news recommendation with Netflix problem, I think news recommendation is harder. Because first, news items are vast. There's tens of millions per day. That's much more than the movies available. And news items are transient. They come and go often and fast, so that item-user relationships are not reliable. And so you have to generalize it before they're useful. If you compare news recommendation with Amazon problem, I also believe the news recommendation is harder. This is more subtle but more important. The reason is that Amazon problem is recommendation based on past purchase, and purchase is a very strong intent. When you do the purchase, you are very convicted. But news reading, the clicks on news document is a weak intent action. So that's much more noisy and less reliable. So the true north of news recommendation is absolutely user satisfaction. But however, how to approximate user satisfaction by online or offline metrics are still open question, and I encourage you to think about it. So there's this idea of leveraging long dwell time clicks and use it as user satisfaction, and also there's the idea of using retention rate for apps, for example. For offline metrics, there's the idea of crowdsourcing. The assumption is you can always find out, you can always have a perfect sample of user that reflect your true user, and they can give you the true feedback. That assumption often does not hold, unfortunately. There's another way that is a defect rate. That assumption is you can always model a user profile to a query so that you can always measure um, the defect rate of recommended news against that query. However, in general, it's really hard or unrealistic to model user profile to a query. Yeah. Next problem that is discover newsworthiness. So this is the critical problem before we even talk about personalization. Um, so one idea is to model spikiness. So there's the idea of leveraging social. Social spikiness is usually ahead of search engine spikiness, as you can see from the plot. For spikiness modeling, the key is to do the D-trend, because you have to remove all those kind of pure article trend, such as weekly trend, daily trend, and within a day there's a habit of user read news twice a day, all those kind of systematic noise that you have to get rid of. Um, but for example, if something is spiking on Monday morning, it's often hard to tell that's really something happening or that's just because publisher start working and users start searching, right? So yeah, so it's a hard problem. When we talk about spikiness, actually, it always associated with certain latency because uh, the you always have to wait until spike happens before you know it, right? So if you want to get ahead of it, the one way to do it is understand publisher. Basically, if authoritative publisher has put something on their headline or top of their page, it's usually something really important, right? This requires very large-scale page layout recognition. So you have to understand blocks by blocks. You have to be able to um, separate them automatically. The other thing, you have to understand those page layout automatically, because for a lot of publishers, they put as the head of news. So you have to identify this particular section is news content, this particular section is as, and you don't mess up with that. Another thing is you have to do real-time topic modeling. First, you have to understand, are publishers, cross-publishers, are they talk about the same story or they're talking about different stories? The second thing is you have to deliver those news, distributed those news to the targeted user. So that requires very fast real-time topic modeling that we're going to talk about later. So that actually requires AI. Finally, we have to get the popularity right. So we have this explore exploit model that is very famous. It's been publicly reported that Yahoo News or LinkedIn using this model and get a very impressive result. So the basic idea is to allocate a few slots and allow low impression topic to be randomly assigned to those slots, and you observe the engagement. And if the engagement is good, then you move them up. If the engagement is not good, then you retire those results and put another set of random selected low impression topic to the slot. This way you can discover the popularity. With the perfect understanding of newsworthiness, we can start talking about personalization. And news personalization is hard. Why? Because we have to always balance familiarity and serendipity. On the first hand, there is this problem of news recommendation because users like to see stuff they're familiar with. So one phenomenon is celebrity phenomenon. So people like to see subject they're familiar with. So for personalization, we have this collaborative filtering, we have learning to rank and get, whatever user read before or similar user read before and recommend those content to the user. But on the other hand, user hate repeated subject. Empirically, we know that engagement is strongly positive correlated to content freshness and diversity. That shows people like to see different stuff. So we have to balance these two. And one of the approaches is to have the hierarchical topic modeling so that we can, when we do the recommendation, we can move up, move down for the drill in, move up for the more general stuff, and move to the sibling for different stuff. So the news recommendation needs and has to be strictly controlled by hierarchical topic modeling. Another way of thinking about problem is do the interactive recommendation, where we can consider cross-session information and also get user feedback in a very timely fashion, also in a very proactive fashion by ask questions. Okay, let's wrap it up our traditional IR overview. So now we know that the whole system is based on inverted index, which is very hard to catch semantics. The whole learning to rank system primarily serves top intent and cannot nail the sub intent very well. The whole system also heavily relies on supervision and has very limited support for interaction. Now let's talk about future. I believe future starts from unmet user needs. That's why I believe personal news agent is our future. Would you like to get the very precise and personalized news notification that only you care about? Would you like to get very precise and hyper relevant news? For example, 3 pieces of news per day and you feel happy about? Would you like to keep chatting with some service and always keep in control and get what you need and based on exactly what you are feeling and thinking at that moment? Would you like to track related topics and share the news across all your social network without effort? Would you like to be able to donate when you read the disaster news and able to contact their relatives when you see a local news that may impact them? Would you like to read a very encouraging news when you feel sad? Would you like to know all the controversial opinions when you have your own opinion to be expressed in social network? When you would like to drill in and get full aspects of a story, would you like to know the timeline, would you like to know the knowledge graph of that story, for example, who's in the story, what happened, and what are the relationship of those people in the story, etc., and etc. Would you like to get all the sub-intents satisfied? For example, when you read news about Microsoft, would you like to know what happens to its competitors at this moment? What happens to its products? What are those leaders in the news? And also there's a super hot content such as live stream, the videos, the VRs, the ARs. I think all that are the future news reading experience. I would say AI, artificial intelligence, is not just a technology, but a framework that enables those future experience. Right? Because the classical one does not understand semantics and cannot do the work that we expect them to do, we have to provide a better framework that will understand social, understand news, understand user, understand image, speech, videos, so that we can provide a rich application, timeline, in-depth, sentiment, conversation, personalized notification, etc., etc. In the latest product News Pro, I believe we're moving the needle a little bit towards the future.
Hi everyone, I'm Yu Mao, engineer of News Pro. News Pro is a Microsoft Garage project that we created trying to redefine the future of personalized news reading experience. Today, I'm going to go through with you the cool feature that you can only find in News Pro, but not in any other app in the world. With one click, News Pro understands their news interests. Your personal news feed is right there waiting for you. You have your news for your interests, news for your company, your skill, and product that you really care about. And News Pro can help track any news topic that you're interested in. For example, I'm interested in Hyperloop these days, and I really want to get informed. So I search for Hyperloop, check the interests, and Hyperloop news is right in the highlight page, and News Pro can keep me updated. See what I got? Microsoft will free up 1 million Xbox gamer tag. This is so exciting, and I got to share with my colleagues. So click on share, select Microsoft employee group, and share it. And see who is commenting my post. Ha, Chen, this is our PM. Let me follow him. If you are tired of old school news experience, the bot is your personal news agent. He can search or recommend news for you. With the assistive keyboard, you always got related topics and stories, and you can chat with the bot all day long. Would you like to know the news about yourself? Try upload your picture to the bot and see what he can do for you. Ha! He's working on it. The bot can find the news for you or for someone who looks like you.
Okay, so now I'm going to give you an overview of AI and how AI could help for personalized notification, how AI could learn the sentiment and learn the conversation, and general AI for learning to rank system. The overview of the AI starts from what and why. So I would like to borrow a couple of slides from Dongyu, my colleague in Microsoft, on this short overview of AI. So what is AI? AI is one definition is a class of machine learning techniques that exploit many layers of nonlinear information processing for feature extraction and transformation and for pattern analysis and classification. So by this definition, the AI is defined by kind of automated feature extraction. So that's the beauty of this. One of the beauty of AI. By another definition, so AI is a subfield within machine learning that is based on algorithms for learning multiple layers of representation in order to model complex relationship among data, high-level features and concept, and this defined in terms of low-level ones. And such a hierarchical feature is called a deep architecture. So in this definition, it focuses on the representation. So that's another beauty of this thing. So AI is so hot, and one of the reasons is it's probably the true north of machine learning, maybe, but nevertheless it's actually very similar to how human brain works. The human brain is actually a very deep system. It has 10 to the power of 14 connections. And human vision and artificial system involves many layers of nonlinear information processing. And there are evidence that shows human brain might use the same algorithm to understand many different modalities. So this is an example of how visual cortex works. So first is a feed-forward processing, and it's very fast, only a few milliseconds per step. And it's one spec per neuron, so it's very sparse encoding, and the processing without context-based help. So you can see that first the eyeball get the signal, and here you see the simple edge and corners are formed, and then the intermediate visual forms such as features are formed, then the higher level features such as face and objects are formed. Then those face and objects are categorized, and then for example face recognition knows who's who, and then you make action should you know running away from this person or smile to this person. So this is very similar to what a very deep neural net is doing. So I personally did some very early experiment in this field, luckily. So when I was a PhD student at UCLA, I luckily involved in collaboration with our neuroscientists, and we analyze and trying to reconstruct image from not from human brain signal, but from I think it's frog brain signal that basically we can reconstruct those images from those signals. It's amazing experiments. Dr. Yu summarized the advantage of deep learning into 3 categories. One is discriminative. So basically, that's similar to SVM that can transform feature from lower dimension to higher dimension so that they're separable. The second one is invariant. For example, pooling that are able to aggregate user from one dimension to new space, so that they can be grouped together. And this deep hierarchy is really the key advantage that deep neural net is. First, it increases the level of abstraction so that you can have different level of abstraction. For example, edge and objects can be in different level, and they have different representation and can be used for different purpose. And each processing stage is learnable feature transformation and transfer the input representation into a higher level. And each high level feature are more global and more invariant. And a low level feature can be shared among categories. So those are actually a very automatically structured way of represent the feature space has its intrinsic value. Okay, now if we can do automatic feature extraction, and if you have a very rich and comprehensive representation of those features, then you can build a lot of rich application based on those features. So that's why we are proposing this new architecture that is very flat. So basically everything, the raw material is at the very bottom, flat, and there's one layer of semantic embedding, so to translate all those raw material into their semantic space. So that's semantic, so like map to semantic space. Or map social data, map news, map user profile, map image, map speech, map video onto that semantic space, higher dimension but a very structured, a deep hierarchy of semantic space. And then all those things like user, news, social, image, speech, video, all those things can be connected by a semantic join. So we can, for example, calculate any semantic distance between any social and tweets and news and user profile, image, speech, and video. Then we can empower based on those rich distance from the deep structured hierarchies. We can accurately calculate timeline, the in-depth coverage, sub intent, sentiment, conversations, and get personalized notifications. So that's really a new framework that enables disruptive new experience in my mind. So in News Pro, we actually shipped one of the personalized news experience. It's just the starting, but I think we're towards the right direction. For example, if your neighbor's child got lost, and you would like to get updated of that information, usually for this type of news, the news will not include the name of the child, but it's often include the picture of that child. So if you upload that child's picture to the bot in News Pro app and wait, and one day you see that smile face, that bot smiled. That means the bot has something new for you. For example, hey, I have the latest story about an image that you uploaded earlier, that a missing Georgia toddler found safe. So this is a technology we built based on a very similar one that I think Takeman presented in CVPR in 2014. I think that's deep face. I think we're using similar algorithms, basically a neural net and multiple deep network. The first one I think is convolution in that paper. The second one is max out. Third one is a convolution again, and then a three-layer of local connected neural net. And using that representation, we can have a perfect representation of any user face. And then we can match this representation, calculate the distance of that representation to any image in the news. And we can have a conclusion to say those two faces are the same face or not. Okay, the bot can certainly smile because of good news. And I believe the bot should be able to cry, smile, be happy, be angry, sad, shocked, or disgust based on what's happening. So this capability depends on a very accurate and very vivid sentiment detection. Luckily, there are tons of research on sentiment detection in the literature. There are research from Microsoft and a few researchers in China. They publish on the ACM in 2014 on their work of doing this sentiment-specific word embedding with automatically labeled social data. They could train a neural net, deep neural net, that do this sentiment, word embedding, sentiment-specific word embedding. And after that, if we leverage this feature in sentiment classification, the classification accuracy can be largely improved. So using similar technology, we apply that to the Italy earthquake. We get insight that the sentiment of this particular event is primarily sadness, followed by disgust, fear, anger, happiness, and surprise. And if you look at the happiness, it's really a certain group of people feel lucky their relatives survive in this vast majority of tragedy and disaster. That's actually very insightful and very surprising. So our service needs to have a very deep understanding of what the user think and what the user feel, so we have a very good, long-lasting interaction with users. Deep learning can support conversation very well. In News Pro, we allow the bot to do very simple conversation with user. The bot is not chit-chat expert. The reason it is not because we are not able to, but we're not comfortable at this moment. If you look at news-related conversation at news site or social network, you will soon realize majority of those conversations are very opinionated, and a lot of those opinions are polarized. At this moment, before understanding its impact to society and to the humans, to the users, we're very cautious. But nevertheless, the science and the infrastructure we have are able to support very complicated conversation understanding and learning. Specifically in AI, there are recurrent neural net that are specifically designed for supporting sequence generation. The key problem in RN including designing its encoder and decoder. In designing decoder, the typical problem is how do you model the long-range dependency. So there were traditional model of long-short memory unit. So basically you add a unit and you decide in the activation function you decide which state to depend on with certain probability. And more recently there are simpler version that is gated recurrent unit that will remove the memory but expose the whole hidden states and use an interpolation function to balance the short-term information and long-range information. In designing the decoder, there were recent work, I think it's from the ICML in 2013, that people empirically discover that the max out function works better than other stuff. So there are lots of interesting and latest work on designing and advancing the neural net to make it more suitable to model sequence generation and of course conversation. News reading with sub-intent understanding can be amazing. Look at this. So knowing the sub-intent around the company, the skill set, the products, the overall industry, the leaders, give this kind of clustered and structured organization of stories so that a user can easily select to drill in or skip. Deep learning has very good support for learning sub-intent. Chen and other researchers published results on NIPS in 2015 on learning sub-intent with CDSSM. C is convolutional, D is deep, S is structured, the second S is semantic model. So basically in this model, they use this very structured neural net and use this kind of cosine similarity dependent cost function so that we can easily measure the conditional probability of given data of any label. So in general, DSSM is a very good, actually DSSM is a very good framework for learning to rank. It has a lot of application on web ranking, and we just talked about intent modeling, A very good thing about DSSM is it's provide a very structured submodel for document query, SAP intent, etc. So it's providing a framework for us to do the intent join. So you can basically do the embedding for semantic embedding for query, do the semantic embedding for documents, do the semantic embedding for any intents, and you can choose to join them when you need. So that provides a lot of flexibility for the applications.